So we want to simplify this expression. Going back to KFC, should we keep it as is? We'll keep it as is if we can't cancel anything. Do we need to factor this? No, we don't have to factor anything, but could we cancel something? Yes, no, maybe. Huh?
Would you say just now?
Would we be able to cancel terms?
Yes.
Yes, so x squared, you lose 1x, y squared, y cubed, you lose 1y. So in the numerator, you will have -5 divided by the denominator, which is x times y. Good. And
The Y on the
come again,
the Y in the numerator.
it got cancelled. It's y cubed, y squared. So y squared will get cancelled. You have y in the denominator.
Okay.
Good. Should we keep it as is? No, things can be simplified. Do we have to factor? No, everything is in factored form already. All I have to do is cancel terms. So both -18 and 12 will get cancelled by 6. So 6 goes into 18 3 times, 12 2 times. X raised 4 divided by x squared would leave me with x squared in the numerator. Y divided by y raised 6 would leave me with y raised 5 in the denominator. So I will end up having -3 times x squared divided by 2 times y raised 5. Yes.
Do you not have to put a 6 on the outside, like the 6 that you took out?
The 6 gets cancelled,
Oh, okay.
right? 6 times 3 in the numerator, 6 times 2 in the denominator.
So it just cancels. Okay.
Cancel 6/6. Should we keep it as is? Clearly not, because the problem wants to simplify. So we shouldn't. Do we have to factor in this case? Yes. One of the most common mistakes I've seen people do is to just cancel out the x and the x cubed, the 24 and the 48. Life is not that easy, right? So you have to factor first, then cancel. So what do we have in common in the numerator? We have a 3, 24. So I could pull 3 out. X cubed in the first term, x squared in the second term. I could pull x squared out. So in the numerator, I will have 3x squared times x minus 8. Yes. Denominator, what is the common factor that I have? 6. So if I pull that out, I'll have x minus 8. What are the common factors between the numerator and the denominator? X minus 8, is that all? 3 and 6. So the final answer is x squared over 2. (24x squared minus 4x). Factor between 24 and 4, there is a 4 in common. Between x squared and x, there is an x in common. So I can pull out 4x if I take 4x out of 24x squared, I will have 6x, because 6 times 4, 24, x times x, x squared. If I take 4x from the second term, I will have minus 1. What is the common factor in the denominator? 4x. So if I take 4x out of the first term, I would have x. 4x out of the second term, I will have 2. So x minus 2. So the 4x in the numerator, 4x in the denominator will get cancelled. So we will simply have 6x minus 1 over x minus 2. Good. What do we have in common between 6 and 2? 2. So I'll put a square bracket so you can understand the difference. What do we have in common between m and m squared? M. What do we have in common between n cubed and n raised 4? N cubed. So I took a 2 out of 6, so 3 is what I'll have in the first term. I took an m out of m squared, so I'll have m. I took n cubed out of n raised 4, so I'll have n. I took out the entire 2n cubed out of the second term, so plus 1. Denominator, 4mn squared minus 8n squared. What do we have in common between 4 and 8? 4. What do we, well, there is no m in common. I see n squared in the first term, n squared in the second term, so n squared. That would leave us with m minus 2. Yes? Now, should we leave it as is? Could we cancel? We can cancel. N cubed divided by n squared, leave us with n. Numerator, I have 2. Denominator, I have 4. So I'll get a 2 in the denominator. So I have m times n multiplied by 3m times n plus 1 divided by 2 times m minus 2. You can put parentheses if you want. I use square brackets to show the difference between